All right, so projectile motion, what we know is, what we can find out is that we can worry about just the horizontal component, part of that. We can then also worry about the vertical component. So we were talking about how we broke things down. We throw it like this. We've got, this is my vertical component, this is my horizontal component, and we can consider those separately. They do not have to be together. Well, I mean, together it's really, really hard to figure out what we're doing, but separately it's a whole lot easier. So that's nice that we can break those down and do that. So when we're talking about a projectile, we're talking about anything that moves through the air or space and is acted on only by gravity or air resistance also. But of course, we're in a perfect world, so we're not going to worry about air resistance very much. So we could be talking about like a cannonball being shot, or if you just throw a rock in the air, or it says a ball rolling off the edge of a table, or even a spacecraft circling the Earth. All of these are examples of projectile motion. And maybe you didn't think of that spacecraft one, but that's an example of projectile motion. It follows that same projectile motion path that we're going to talk about here. And if we're near the surface of the Earth, we follow a curved path. It looks kind of complicated, but after you break it down, you'll find out it is very, very simple to break down. It follows some patterns. And let's break that down right now. Let's say, for instance, that we're talking about projectile motion, and we're talking about just the horizontal component of it. And if we have this, notice that the ball is always, there's the same amount of distance between each of those. So we're talking about the same time frame. And it's constant. As we go this way, horizontally, this is a constant speed. Because once I've let go of it here, I'm no longer accelerating that object. It's no longer being accelerated by horizontally. It might be accelerated by gravity down, but not horizontally, only down. So at this point, it's just going across, going away, and it's going at a constant rate. Assuming there's no friction or air resistance, it would keep going at this constant rate forever. Oops, I always mess that up. Got to click this off first. Okay. Now, let's say that we drop the ball at the same time. Now let's take a look at how it's dropped. And notice that in the first second it goes just a little bit. Second second it goes farther. Third second it's going to be even farther. So this one, it expands, it accelerates as we go because it's being accelerated due to gravity as you go downhill. What we want to do now is put those two things together. See, what's happening is the ball's moving this way and it's moving this way at the same time. So this one, that should be over, from here to here. This one needs to move over there that far. And then from here to here, this one needs to move over, twice as far is what we're talking about here. So we're going to put it all together, and I did that again. If I don't click off on my marker when I hit the advance button, it wants to stop the slideshow. Okay, so the most important thing now for us is that we've got the horizontal component completely independent of the vertical component, and we can break those things down when we do that. Okay, so now let's talk about projectiles launched horizontally. Let's say you throw it out horizontally. Okay, so here's an example of a strobe light photo. So what they did is had a strobe light taking a picture of this every, probably, I don't know, 50th of a second, 30th of a second, who knows. And they're taking a picture. And this particular ball, the yellow one, is thrown out this way. The red one is just dropped straight down. But notice as we do this that these, let's see where we at here. These match up. They're pretty close. They're not exactly perfect here, but they're pretty close if we look at where these things are as we go through here. I think this one is somewhere in there. But notice that the acceleration due to gravity is the same on both of them. They're pretty close there, pretty close there, pretty close there. Even though this one is still moving to the right. So despite the fact that it's being thrown, it's moving this way, it's got some horizontal component, its vertical component, its acceleration due to gravity is still the same. It does not change at all. It doesn't matter how fast you go. So if you're here and you've got this gun and you're firing a bullet, and somebody else is standing right here, and they drop a bullet at the same time that you fire it, they're both going to hit the ground at the same time. Even though this one might have gone, a mile or however far it can go in that amount of time. So now, and I'm talking about if you fire it straight out, not if you fire it at an angle up, but if you fired it straight out, because the component pulling it down there is the same as here. The acceleration due to gravity on both of those is exactly the same. It doesn't make a difference. All right, so it says there are two important things to notice in this photo. One, the ball's horizontal component remains constant, and both fall the same vertical distance in the same time. Okay. So the ball moves same horizontal distance. Each interval path traces a projectile accelerating. The path traced by a projectile accelerating in the vertical direction while moving at constant horizontal velocity is a parabola. So when we throw this, we throw it straight out, it's going to look like a parabola. If there's no air resistance, it'll be a nice, perfect parabola. If there's air resistance, it'll change that just a little bit. All right, so think about this. At the instant a horizontally pointed cannon is fired, cannonball at the cannon side is released and drops to the ground. Which cannonball strikes the ground first? The one fired from the cannon or the one dropped? Well, if you can't answer that one, you obviously weren't paying attention. So they both are going to hit the ground at the same